Let's look at numbers and numerals now and try to find a definition or differentiation between the two, where we see that numerals are more like alphabetic representations, alphabets like letters, whereas numbers are the actual values like words. So you use numerals to build numbers. In the same way as you use letters to build words, you use numerals to build numbers, right? Or to represent numbers. Numbers represent value. Numerals are just the vocabulary, or rather the alphabet that are used to represent numbers. So just like with your alphabets, your English alphabet, you can have a letter A and a letter M. You combine the two, you get the word M, like I am. Right? Yes. Similarly, you can have the numeral 2 and the numeral 5. You combine them, you have 25. But at the same time, just as with your letters, you can have A. It's a single letter, but at the same time, it is a word in its own right. A is a word in its own right, a single letter, a one-letter word. So similarly, you can also have a one numeral number, like 5. 5 is a number that's made up of one numeral. So you can look at 5 as a numeral or as a number, depending on what context you are in. Having said that, let's look at our numeral system, where we're going to say that we've got several numeral systems. Numeral system is just a way of, it's just like choosing the alphabets that you're going to be using when you are writing in your orthography. You may be familiar with the fact that we've got Chinese alphabets, we've got the Latin or English alphabets that we're using right now. We have different types of alphabets like the Arabic, the Russian, the Greek. We've got all those different types of alphabets. So the same thing here applies with the numeric system. When you talk about numeral systems, we are referring basically to the alphabets that are used to represent numbers. So the most common numeric or numeral systems that we use in the world today are the Arabic numerals and the Roman numerals. The Arabic numerals are the ones that we generally use. That 2.1, that's Arabic numeral system. Okay, this table here shows some Arabic numerals and the Roman numeral equivalents. The concept of using Roman numerals, it's quite easy actually once you get the grasp of it. It's actually fairly enjoyable when you actually then get to use it. Because there's about, I think, 6 or 7 different digits or different figures, different types of numerals. And then those numerals will be combined in different ways to create values. The first one there would be the I, which represents 1, and then V would represent 5. So if you put an I before a V, it means 1 before 5, which is 4 really. Or VI, that's 1 after V, which is 6. In the combination, we can have up to 3 of the same figure being repeated. So you have the I to represent 1, II for 2, III for 3. And then after you have 3 of them, you then move to the next value, which is the V. You say 1 before V. That's how you write your 4. So you then combine, you remember we had V1 for 6, VII for 7, VIII for 8. You've already used up 3. So then you have to introduce the next letter, which is the X for 10. So 9 becomes 1 before 10, IX, etc. We continue using that same logic into our hundreds, 50 there being L, 100 being C, 1,000 being M, and what else are we missing there? 500 being D. Okay. Having said that, let's move on to the number systems now, where we are going to say that number systems are now a system, an agreed on way of depicting or using numerals to depict numeric value, depict numbers. So you can have all these different numerals, but we agree on how we combine the numerals to give you a value. So the most common number system that we use is the 10-based system, or the base 10 system, otherwise known as the decimal or the decal system. This is most likely because humans have 10 digits, fingers on the hands. So I think that is why we ended up having this combined, universally accepted base 10 system. However, this is not the only case that exists. We can also have other representations, as we are about to see. Okay, first of all, we have our base 10. It's made up of 10 digits, and as you see, the smallest of them, the smallest numeral there is 0, and then we combine them to get a value. What you simply do is, to get the next value, an increment, you move along the units line, starting from the smallest up to the largest. So once you get to the largest, which is 9 in this particular case, you then increment the tens. Call them tens? Yes. So when you increment the tens, you now have 1 there, and you restart the counting. That's how you get your 10. You restart your counting. That's why you have your 10, which is 1 and 0. And then 1 and 1, 1 and 2, up until you get to 1 and 9. 9 is the largest. So when you get to 9, you increment your tens to get a 2 in the tens position, and you restart the cycle in the units position. Also have the 0, 20, 21, all the way up until you get to 99, and you just increment by adding the hundredths position now, and everything else, the tens and the units, are reset to 0. So I'm just going to skip this for a while. I'm going to go back to that in a very short while. Another system that exists, like we said, there's 4 of them. We look at the base 8, or the octal. This is used a lot in computer science, mainly because of the sizes of bytes and bits, memory storage units. Not physical units, I mean the measuring unit of measure of memory is called byte, and each byte is made up of 8 bits. So we tend to have several applications that require the use of base 8 numbers in computer science. So what happens with base 8 numbers is we only use 8 different symbols, which basically means the symbol for 8 and the symbol for 9 do not exist in the base 8 or octal number system. So when you calculate, or when you use your digits, you'll see that you start adding in the same way as you did with your base 10 numbers, up until you get to the largest 1-digit number. In this case, it is 7. After 7, you reset, you go back to 0, and then you increment the tens. So you have 11, 12, 13. What looks like 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 27. After 27, you get to 30, and all that. Now, for better appreciation, remember that what happens with 9, after you have 9 in your base 10, the way you increment from 9, that is exactly how you're going to view your 7 when dealing with base 8. You're going to view 7 as if it's 9, because it is the largest possible digit or numeral that can be used. Okay, so that's our base 8 numbers. We move on to base 2, binary numbers, also used in computing a lot. For binary numbers, what we have is only 2 symbols, the 0 and the 1. So obviously then when you increment, it's almost like the 0 acts as a 9. So in other words, where you have a situation where you've got a 9 and a 9, which is 99, the next number that would come after 99 would be 100. So So in this case, if you've got 1, 1, it's more like you have 99. The next number that comes after the 99 is 100. Or in this case, after the 1, 1 is 100. So binary numbers are also used a lot in computing, mainly because of the nature of computers. Computers work on a binary system. And then finally, we've got hexadecimal numbers. These are not the only systems that exist. You can actually create your own. So it's very simple. Just say base 3 if you want to use it. It's very simple. You can, because the logic is the same. But these are the 4 that are more common, that are actually used. But like I said, if you want to make a base 12, you're free to do it. If you want to make base 5, you're free to do it, because it actually exists in principle. Anyway, we are using base 16 as well. Base 16 uses 16 different numerals. So in this case, we now borrow the first 6 letters of the English alphabet to represent the remaining 6 digits, because notice that we only have 10 alphabetical symbols for numbers in Arabic digits. So we are going to be forced now to take A, B, C, D, E, and F. So any number that contains any combination of any of those 16 is actually a valid number. But if it's got a G, or if it has an X in it, then it's not a number. It's only a valid number if it goes all the way up to the letter F only. So one full cycle there. Remember, when you count, you go all the way up to the F. So you'll see in the examples given down there, you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, we don't go to 10, we just continue. A, B, C, D, E, F, and then F is the largest possible value. Therefore, after F, we rotate, similar to what we would do if it were a 9. You restart the cycle and increment the tens. So after F, you get 10. After 1F, you get 20. After 9A, you get 9B, up until you get to 9F. After 9F, that's when you get now A0, A1, A2, up to AA, AB, AF. Once you get to AF, you start the new cycle with B0, B1, B2, up to B9, BA, up to BF, etc. Up until you get to FFF, in which case the next digit would then be, you replace those 3 F's with zeros and start a new significant figure allocation. So you'd have what looks like 1000 coming in after FFF. Like this video and subscribe to this channel for more such content.